In this training session, we're going to take a look at the anomaly detection feature of event log filters in EventSentry. I'm going to give you a brief overview of how you configure this in the management console. And then we're going to take a look at some of the diagrams and theory behind it. And then we're going to come back to the management console to look at it in a little bit more detail. So if we look at the event logs packages here, there's a package called Anomaly that I created and that will also ship with EventSentry. And we can see here that we have a number of filters, and we see that the first three filters have a different icon, and this icon here essentially indicates that these filters are anomaly filters. So if we click it, we can see here that there's a type anomaly here that is there in addition to include and exclude. So what that means is that this particular filter here will not actually send out a notification, and you'll notice that there is no action area up there. So that's missing. Whereas if we go down to a regular filter, we do have an action control up there. So this is how you essentially convert a filter into an anomaly filter. Now the filter still works the same way a regular filter does. It would still be applying to certain events here. In this particular case to 4688 events when a process starts. We have some exclusions here. And obviously we can see that the anomaly button here exists. So if we click that, then here is where the actual anomaly settings are configured. And that's something I'm going to explain in a few moments. There's a learning period and there's keys and values that need to be configured. The idea behind anomaly detection in EventSentry is that we define relationships between keys and values. In this particular case, a user and processes. So that would be here. If we look here, we can see that we have user ID, so that's the user, and then we have values here, and that we have a learning period. So the EventSentry agent in this particular case would learn for 1 day which processes a user starts, and if a new process that was previously not detected is launched, EventSentry will mark this event a certain way as an anomaly. And we can then decide what we want to do with that event. If we want to send an email, if we want to require acknowledgements, and so forth. So let's take a look at the first example here, where we're trying to detect processes that are usually not running, that we would consider an anomaly. So what we're doing here is we're looking at the 4688 event, all its insertion strings. And we're, of course, interested in two things. We're interested in the username, of course, because that's with whom the processes are associated with, and the actual process. We're using a combined key of two fields here, the security ID of both areas, target and creator subject. And the only reason we're doing that is because sometimes the username shows up in the insertion string number 1 and sometimes insertion string number 10, depending on if it's run as administrator, etc. But I don't want to go too much into detail with this one, so let's just remember that we're creating a key based on both of these together. And then we have values that we are associating with that key. So if we look at over here to the right, and let's just imagine we got user John, and he normally starts Notepad.exe and cmd.exe. Obviously, these are oversimplified examples, but this is just to illustrate the purpose of this feature. And then we also have the user Jack, who is also logging on to the same, let's say, server, and he always just runs mmc.exe. And then we got user Joe, and he runs cmd.exe, xl, and ping.exe. So these are now associated with these keys. So here's the key, and these are the values. So after 24 hours, or however long the learning period is, EventSentry has an established association between those keys and its values, and any new process that comes along will now be considered an anomaly. So if user Jack suddenly launches systeminfo.exe, then it's not contained in the existing list of processes, and it will be considered an anomaly and flagged as such. Now let's take a look at another example. Now we're looking at the security event ID 4624, which is a logon event by Windows that's logged when somebody successfully logs on to a server or workstation. We'll notice that this time we have a more simple key that simply looks at insertion string number 1, security ID, and then we have the values that are now combined with insertion string 5 and 9. So this is obviously a lot different than the previous example. And the key difference here is that insertion string number 1 here will always be the same value. It would always be in tier 30 system. We could also use the account name, which would be the name of the computer, but it really doesn't matter. And the reason why is because we're simply trying to detect new logons to the computer. So we don't have that multi-tier setup that we would have with the processes where we associate processes with users. In this case, we only have one computer, which is the local computer, which we care about, and we want to know who logs on to this computer, and we want to know does somebody who normally does not log on now log on to that host. So as a user logs on, let's just start with the first one. The domain user Bill logs on locally, with his actual keyboard. EventSentry records this and says, okay, domain user Bill has logged on with 2. Now let's say Bill goes home, logs on with RDP. EventSentry notices that, records it, it's all set and considered valid. And going back to those learning periods, those will want to be adjusted depending on the type of data that you're looking at, right? So for something like processes, it may be longer. For something like a logon, it may be shorter. So it really depends on the circumstances, right? If a user usually logs in every day, then a learning period could be a couple of days, and that could be sufficient. But of course, obviously, the longer the learning period is, the fewer false alerts you're going to get, but the longer it's going to take for that feature to become effective. So now let's say this is a shared computer, and for some reason, Jack also logs onto this computer, and Bob log on, and Don, they all log on to this computer. Let's say the learning period is a week, and during that week, these users log on locally. Now, after the baseline has been established, EventSentry considers only these user accounts, these combinations of users and the logon type as regular, if you will, and any new combination will set the anomaly flag or associated with that event. So if Don now logs on, but doesn't log on locally like he did earlier, but logs on with remote desktop, then that will be flagged. The same goes for a completely new account. So it wouldn't really matter how George logs on. He has never logged on. So if he logs on with a keyboard, then that will also be considered an anomaly. Now, once they are recorded, however, they will be incorporated into the existing list, and you will not get notified again, or the event will not get reflagged if they log on again. So if Don logs on with RDP again, then it will not be considered an anomaly. And what's really powerful about the anomaly detection is that it's a very flexible system that gives you complete control over how you want to detect these anomalies. So for example, in this case with the logons, in the example here, we created values that associate the username with the logon type, but you don't have to do that. If you just want to use the security ID without the logon type, then you can do that as well. And the result will be that it won't matter how a user logs on, whether it's RDP or a batch job or a local logon. If they log in again, whichever way, they will not get flagged as an anomaly. So probably fewer false positives, possibly maybe a little bit less security, but in any case, you have full control over that and how you want to configure that. But let's go back to the management console so we can actually take a look at how we configure all of this. So we already went over that process start filter, so I already explained how that works. The only thing to keep in mind here is we are excluding some events that tend to cause a lot of false positives. So in this case, we're filtering out some of the parent process names. So if a process was started by any of these, and you can take a look, we're actually filtering on the exact path, which would increase the security, then those processes will simply be ignored. Anomaly will never be set on any process that's launched by any of these 3 parent processes. Logon user, so let's take a look at that. So this is pretty much what we looked at just before. So we have a learning period of 1 day. Again, these are things that you will probably want to adjust. And then we'll take a look at the key here. So key is subject user sys. So we said this is always local system. And then we have the logon type and the target user SID. So we're actually going by the SID to make this completely unique. And you can create more values as well. So if you decide, okay, I want to also add another string, let's say insertion string number 3, domain name, then you can do that. So now if EventSentry does detect that something is considered an anomaly, what happens? What happens now is an event that passes through this filter and is considered an anomaly will be flagged as such. And we can then use that flag to do something else with it. So that could be another filter that simply looks for that flag, that then sends an email, submits it to a website, to a ticketing system, or flags the event further. So for example, here we have a filter that does exactly that. So this is a regular filter now. So this is not an anomaly filter, just a regular filter. And what happens here is we have the advanced button, and there's an option here that says process events with anomaly. And normally this is set to any event. So this would be normal filters will just process any event, of course. But here we're saying, okay, anomaly was detected. And if that happens, so this filter will only apply to events that were previously flagged by any of these filters, then we can set the require acknowledgement flag. And that's all we're actually doing here. So this filter does nothing but essentially intercept any event that had the anomaly detected and flags them with the require acknowledgement. One thing we'd have to change here, of course, would be the action. This is set to default email, but for the anomaly to really, for the require acknowledgement to work well, we'd want to use the primary database. It doesn't really have an effect for emails. And so now, once events are detected as anomalies, we can actually search for them in the web reports by only looking at events that require acknowledgement. You may already have other ways or other reasons to require events to be acknowledged, but this would be a new reason. This would be another way to do that. One important thing to know is that any event that gets flagged as an anomaly can also be filtered in any of the compliance, security and compliance tracking packages. So for example, if we go to the features process activity, for example, if you click here, we can see that there is a new is anomaly field. So you can use this and say yes to only see processes that were considered an anomaly. The same goes for logons, for example. So all the compliance tracking features now have the is anomaly flag. Now there is one setting that I have conveniently ignored, and I saved that for last. If you go back here to the management console and look at the process start anomaly settings, you'll notice that there's a separate learning period for new keys checkbox here, and it's checked here for the processes. But if we look at some of the other ones, the logon user, for example, it's not checked. And let's take a look what that setting does and why that's important. So let's go back to the process start anomaly settings. By default, the learning period that's configured, and the learning period is important, affects everything, every event that passes through it. And after the learning period is over, anything else that is considered an anomaly will be flagged as such. And that will work for something like the logon filter, but it's not going to work well for the process start event, for example, because there are different keys. So for example, if you consider a learning period of 1 week, and user John logs in on Monday, and John launches all sorts of processes throughout the week, the processes that he always runs, then by the next week, if he launches something that he'd never launched before, it will be flagged as such. Somebody can review it and then determine, is this an issue or not. Now, if user Jack logs in the next week, and let's just say this is a shared computer and there's different shifts, and user John works week number 1 and user Jack works week number 2, then anything that Jack will launch will be considered an anomaly because that combination had not been seen before, that process had not been seen before. But by checking that box, by activating separate learning periods for each key, in this case, each user, will have their own learning periods. So that means once user Jack logs in and starts the first process, that's when his learning period will start. And that makes a lot more sense and avoids a lot of false positives. So for anything that has unique keys that are tied to something like the user, for example, a separate learning period for each key makes a lot of sense.